Hello and welcome to Scientific Concepts. This video is about very basic scientific laws and theories. Number 10. The Big Bang Theory. The Big Bang Theory postulates that the universe began almost 15 billion years ago with a massive expansion event. At that time, the universe was confined to one place, encompassing all of the universe matter. That original movement continues today as the universe keeps expanding outwards. Number 9. Hubble's law of cosmic expansion. In order to quantify the velocity of the magnetic galactic movement, Hubble proposed Hubble's law of cosmic expansion that can be explained by an equation. Velocity is equal to h0 into distance, where h0 is Hubble's constant. Distance is the galaxy's distance from the one with which it's being compared, and velocity represents the galaxy's recessional velocity. Number 8. Kepler's laws of planetary motion. Kepler proposed 3 laws for planetary motion. Kepler's first law is called Law of Orbits. It states that planets orbit the Sun elliptically. The second law is the Law of Areas. It states a line connecting a planet to the Sun covers an equal area over equal periods of time. In other words, if you have measured the area created by drawing a line from Earth to the Sun and tracking Earth's movement over 30 days, the area will be the same no matter where Earth is in its orbit when the measurement begins. The third law is the law of periods. It allows us to establish a clear relationship between a planet's orbital period and its distance from the Sun. A planet relatively close to the Sun, like Venus, has a far briefer orbital period than a distant, like Pluto. 7. Universal Law of Gravitation. More than 300 years ago, Sir Isaac Newton proposed this law. Any two objects, no matter their mass, exert gravitational force towards one another. F is equal to G into M1 M2 by R2 is the equation. F is the gravitational force between the two objects, while R is the distance and G is the gravitational constant. Newton's laws of motion. Newton's first law of motion is an object in motion stays in motion unless acted upon by an outside force. For a ball rolling across the floor, that outside force couldn't be the friction between the ball and the floor, or it could be the toddler that kicks the ball in another direction. Newton's second law is F is equal to m into A, where F is force measured in newtons, m is mass, and A is acceleration. Force is also a vector quantity, meaning that it has a directional component. Third law states every action has a reaction, and the reaction is equal and opposite in direction. That is, for every force applied to an object or surface, that object pushes back with equal force.